Hi, everyone. Good morning, good afternoon from wherever you are attending. Thank you so much for attending this exciting webinar. Uh, we do this on a monthly basis. It's on a recurring basis every month, and we run these in different time zones as well. So thank you for attending in whatever time zone you're in. We have an exciting webinar today because VMware and Google is partnering to present you this topic on scalable and secure app delivery across hybrid environments. We have Marcus joining in from Google, and we have Abhinav joining in from webinar. Welcome, Marcus and Abhinav. Um, I just have a few housekeeping guidelines before I turn it to them to begin their presentation. This is about 60 minutes long presentation. We have a mix of presentation and demo. Let's keep it interactive. Please engage in Q&As. We would love to answer all your questions. You can put your questions in the questions panel down there, and one of us will definitely take it and answer it along the way. Now, this session is being recorded. You will get the recording as well as the slides in a follow-up email, so don't worry about that. And if you find the content really useful, then feel free to share it with your other coworkers who are not able to attend this webinar right now. Yeah, so without further ado, I'm going to pass it on to them. Abhinav, if you can just go to the agenda slide. So yeah, quick, we have an action-packed agenda for you all. Marcus will be going over, customer requirements to, what are the customer requirements to migrate to the cloud, and what better way to hear it from Marcus directly. And then, the NSX Advanced Load Balancer or RV Networks, we will go over the overview of RV and Google hybrid and public cloud. Then, what are the legacy load balancer challenges, and what is the solution that RV offers to counter those challenges? We will take you through the architecture for RV and Google Cloud VMware Engine, and use case and benefits on the real deployment scenarios. And then Abhinav is going to lead you into a very interesting demo. So without delaying, Marcus, it's all yours. Please take it off.
Thank you, Survi. Thank you, Avinav, and thank you everyone who's joining us today. Happy to be here and partnering with VMware to deliver this content. It is no secret, and everybody knows, that public cloud has seen tremendous adoption over the last few years, and Google Cloud VMware Engine specifically, which is our VMware as a service offering here at Google, is not an exception to that statement. We have seen in our relatively short history since we launched the service in June of 2020, tremendous growth and tremendous adoption by customers coming to GCVE, to Google Cloud VMware Engine, to satisfy a wide range of use cases. We're listing here the primary ones that we see, and they range, like I said, from application modernization, customers wanting to be closer to native cloud services to enhance their application usability and application architectures, to all the way to DR in the cloud. So, and we have customers in production doing each one of these. One that is of particular interest, especially now in the times of pandemic, has been data center expansion, basically cloud bursting to GCVE to provide seasonal capacity in these dire times. And also a lot of customers just exiting the data center for a variety of reasons, because they want to consolidate, because they want to fully embrace the adoption of cloud, and they want to leave their colos, and there are some other motivations. VDI also remains a top use case for GCVE in cloud. And the main point of today's presentation is that we're going to show you how the NSX Advanced Load Balancer, specifically for Google Cloud VMware Engine, provides value across this landscape of use cases. So if we can go to the next slide, we'll show you that the proof is in the pudding. The NSX Advanced Load Balancer, also known as the AVI Network platform, has been GA and available in native Google Cloud for a while. In fact, one of our most prominent success stories and largest customers in GCP, PayPal, which everyone is super familiar with that brand, extensively uses Avi networks to provide seasonal capacity and elasticity during specific peak periods of the year. This platform is helping them deliver enterprise grade auto scaling. It's also enabling them to deliver service level to internal and external customers, providing elasticity as well as the ability to self-service all this capacity when they need it. And one of the most important aspects of the NSX Advanced Load Balancer is that it normalizes the consumption experience across public and private cloud. So if you have a hybrid deployment of cloud, by putting NSX Advanced Load Balancer on top, you were able to create a consistent experience for the needs of your applications, irrespective of where these applications are located. But today, we're going to focus on a new capability, which is the NSX Advanced Load Balancer integration with GCVE specifically, where our VMware as a service offering here in GCP. And that is what it's going to basically, that's going to be the bulk of the presentation. So with that, I'm going to pass it on to Avinav.
Thank you, Marcos and Surbi, and hello, everyone. So as Surbi and Marcos mentioned, we're going to tag team on this and have a conversation. Please feel free to put your questions in the chat windows, in the Q&A window. So a very quick overview of Avi. Now, I don't think we need any introduction anymore. We have been in the industry from 2014. We are a software-based load balancing solution. When we were founded in 2014, we wanted to ensure that we are ahead of the curve in terms of providing a fabric approach to load balancing, something which you've already seen with the likes of vSphere and vCenter for compute, as well as NSX for networking. Right. So with that, what we do is we do all the required items for an application delivery controller, including local load balancing, global load balancing or GSLB, an application security stack, including DDoS through web application firewall. And we do this in a very consistent way, as Marcus mentioned, across on-premises, public clouds, as well as hyperscaling solutions such as Google Cloud VMware Engine. Right. In addition, post-acquisition in 2019, it's been over a couple of years now. We've been working very closely with VMware and solutions and infrastructure components. For example, VMware Cloud Foundation, which is underlying the GCVE stack as well, along with solutions like modern application systems like Tanzu, as well as observability and manageability feature sets, for example, VRNI, VRO, VRA, and of course, anywhere workspace with Horizon. So before we get into the details about the GCVE and GCP integration, just want to set the stage with what exactly was in our minds when we came up with with Avi, why Avi was born. So prior to Avi, what we've seen is that even today, the legacy load balancing solutions have been there. They're great in terms of feature set, but they are basically a monolithic model. So they have an active standby pair. You procure them, you put them in your data centers. If it's a virtual load balancer as well, it is just taking that same item and then packaging it as a software, right? So it is not distributed. The disadvantage of that becomes a multifold, especially in today's modern architectures with public cloud as well as hyperscaling solutions, right? So first of all, capacity management. Today, we don't want to manage these as discrete elements in your network. What you want is an intent-based solution where you say, I need capacity for my load balancing, go figure out where it is available, and then just give that to me almost as a service, right? So that's something which is missing. The second is a byproduct of that is also the control point and complexity. So operationalizing it piecemeal, everyone on its own, automating that, those are also very complex. So what we really are missing is a more centralized approach in terms of management. Right? That is also something which is one of the reasons for public cloud success as well, because they have provided a very good control plane from which to manage your services. Right? Third, there is always a challenge given the current complex environments and so many vendors, so many appliances running, as to if an issue happens, then who is to look at the troubleshooting aspect, right? What is the observability? And what we've seen is that although the load balancer has been in line with the traffic throughout, there has been a challenge in terms of presenting those insights which a load balancer can do. And that's something which we've worked on very, very nicely. You'll see that in the demo. And finally, as you can see from this, the net of this is that these are not been designed for modern challenges, modern applications, where you have the same application, you want to run it on premises, you want to run it in cloud sometimes. Sometimes you want to run, migrate to a container-based refactored systems. So that's is there something which can be consistently take the best of feature set, but be able to abstract away the complexity so that as an application owner, your teams, you as an application owner are getting the same consistent, seamless experience. Right. So that's what Avi provides overall. What we do have is a modern architecture where the control plane is all fungible. It is amalgamated, and then that provides the services into the data plane or into the data center. The other challenge which we see is also in the public cloud space. So over here, we have a couple of options. One is the legacy load balancing solutions, which I just mentioned. And there you get all the enterprise grade features, but as I just said, the trade-off over here is that you do not have the cloud native capabilities. On the cloud provider load balancing systems, again, there are great products, but what happens over there is that while you get awesome multi-cloud, cloud nativity, in terms of automation, in terms of APIs, some of the features which you have already been using on the on-premises side, they tend to be a gap, right? So the question which most of our customers migrating into cloud or extending into cloud have is, can I get the enterprise grade feature set, but with that cloud native automation and cloud native approach? And absolutely you can with a modern load balancing solution like Avi. So I've just gone through this, so won't spend too much time on this. But as I mentioned, the Avi system, or NSX-ALB, Advanced Load Balancer as it is officially called, has two distinct components. One is the control plane, which is a controller software running either on premises or in your public cloud, in your Google VPC, or in your GCVE SDDC, wherever your applications are. And the controller will then connect to the underlying ecosystem where the applications are running. So it'll connect to the vCenter, it'll connect to NSX, it'll connect to the GCP API systems, and it'll provision the data plane entities, which are other, which we call service engines. These are the compute instances which are in the data path and do the actual load balancing. So with that, the controller is the one which deploys these service engines, does all the configuration, and then the service engines are all managed by the controller. You do not have to go and figure out which NIC on a service engine VM has to be tied to the application subnet, which has to be on the web subnet and all of that. That is the beauty of this system. With that, what we get is a centralized orchestration. So all of the challenges which we just mentioned are, we intend to solve, we have tried to solve that using this architecture, right? We get elasticity in terms of scale out, scale in. Demands when your application grows, the load balancer can also grow. Resilience in terms of it being fully active. In fact, we have a slide later where we see how we've gone through 1 million transactions per second on public cloud on Google way back in 2017. Right? And fully automated with SDKs, REST APIs, Go SDKs, Python, whatever is your poison, and then of course the analytics and observability part. In addition, I just want to spend just a minute on the web application firewall as well. Typically, we have seen WAF as being yet another product which you have to configure, configure, deploy. It adds to another hop. And with that, the other main challenge with WAF has been that WAF is very complex to manage, and to maintain. So what we've seen, a lot of customers we talked to when we started building our WAF is that they do procure WAF, but a lot of them put it in a detect-only mode, or they just use it for compliance. So with Avi, the WAF journey has primarily been with having, trying to leverage the Fabric approach, the observability, and the UX, the user experience, which we have, to provide a very functional WAF, which is actually used. So in an intuitive way. And we'll see, try to see that in the demo. Otherwise, we do have other webinars which go into the details. Right? In addition to WAF, which is again on the same load balancing, same virtual service, you just have a click of a button and you can enable WAF. We also have other security components or security features outside of WAF, which is part of the load balancer itself, right? For example, things like bot detection and bot management, DDoS protection, SSL offload and SSL re-encryption, of course, is a very, very basic feature for load balancers. And then things like, layer 7 firewall, application rate limiting policies. Right? So with that, you have a full application security stack available for you along with the load balancer. As I was talking about the auto scaling capabilities, just a data point. We did this, in 2017-18. When a customer asked that, yeah, you talk about auto scaling, but can you really do that? And in this case, what we had was a controller which automatically deployed in a matter of 15 to 20 minutes, service engines automatically on. So we started running traffic from the client to the servers on GCP, on Google Cloud. And then these service engines automatically scaled up, seeing the load increase. Once it hit the 1 million, we shut down the traffic, and then it auto scaled back in. So we paid around 40 or 50 or $100 for a couple of or 3 hours, I don't remember, to do this entire test. That provides the effectiveness of this architecture and of using public cloud capabilities from Google on this. So I'll hand it back to Marcos to get more details about Google Cloud VMware Engine and the Google ecosystem before I get into more of Avi.
Thank you, Avinav. Yeah, here we would like to take a step back and just restate what GCVE is for those in the audience or watching us, watching this later, don't know what this offering is. Google Cloud VMware Engine, our VMware as a service offering here at Google, is a fully validated software-defined data center stack that we run on Google hardware inside of Google Cloud. It is a first-party service, and this is one of the biggest differentiators when compared to some other offerings by other cloud scalers. And what that means is that we own, operate, and maintain the service with VMware in the background providing design and escalation support. Google Cloud VMware Engine is native VMware components assembled, tested, and validated by both VMware and Google that provide operational consistency. This is one of the main and most successful use cases that we've seen, or motivations, I should say, where customers want to have in Google Cloud the same management and operational experience, leverage the same tools and skills that they have for their on-prem VMware capacity. It is completely integrated into our Google console and cloud portal, and it provides a set of APIs and CLIs that allow you to programmatically consume this infrastructure. It is available globally. We're currently in 12 regions around the world, and adding a region seems almost every month. And because Google Cloud VMware Engine is adjacent to Google Cloud, this allows the consumers and customers of GCVE to access the native services that, as I was mentioning at the beginning, can enhance the application experience that they're trying to deliver to their users. Next slide, please. We see GCVE, and going back to my original statement, addressing a number of interesting and high-profile use cases, but it doesn't mean that we don't have our own set of challenges. And this is where the NSX Advanced Load Balancer is going to add a lot of value in order to address these challenges. The first one is scalability and performance. Obviously, everything in GCVE is virtualized. there's no opportunity to insert a hardware appliance. So when we talk about elasticity and application availability and security, we have to look at solutions that provide a seamless scalability in a virtual form factor. And NSX Advanced Load Balancer satisfies that. Also, there's a lack of operational visibility and analytics. If you think about the traditional load balancer that has been included with the NSX platform for years, while it satisfies some use cases and it provides value in some cases, it falls short when it comes to providing operational visibility and deep analytics into what exactly the traffic that is traversing the load balancing tier is doing and how it could be optimized. And as great as our native load balancing offerings are in Google Cloud, they are distributed by nature, globally available, highly resilient, they are not yet integrated with GCVE. So what that means is that I cannot take a native load balancer that I would probably use, or I would likely use for applications running natively in GCP, and use GCVE as a backend. That is, those features and capabilities are being worked on. So, but even when we are able to deliver that, we will still need enterprise-grade capabilities that customers are used to, that perhaps those native load balancers won't be able to provide. And this is where the partnership with VMware and the support of the NSX Advanced Load Balancer inside of GCVE becomes extremely important. And then, as Avinav mentioned multiple times, operational consistency and support is extremely important. When things fail, and they inevitably will, you need to have the right instrumentation to understand the problem and address it in a timely manner. And if you can do that across the board, and as I mentioned earlier, without necessarily worrying about where the application backend lives, that is going to provide a much better experience. So next slide. This is specifically how the NSX Advanced Load Balancer addresses those challenges that I was mentioning earlier. But in terms of scalability and performance, the AVI Load Balancer is elastic by nature, can scale on demand as the application requires it. It also can scale in hybrid cloud deployments, of course. The operational visibility and analytics is perhaps the superpower of this platform. As a shameless plug, I gotta say that I had the distinct pleasure to be part of the due diligence panel for the AVI acquisition back when I was at VMware, and the troubleshooting dashboards, the visibility that the AVI platform provides was really what won the deal. It is superior, it is extremely sophisticated, and it provides instantaneous value to customers wanting to understand, like I said, the application patterns in their implementations. And again, this goes back to what we've all been saying: consistent operational support in multi-cloud or hybrid cloud deployments. Next slide, please. Okay, I'm gonna pass it over to you, Aminat, to talk about the specific integration in GCVE.
Yeah, so what we've tried to do in this case is get the benefits of the automation, the southbound automation, which we have, the integration where the controller can talk to any of the environments, right? We learn the environment, we discover it, and then we basically insert ourselves over there. So there has been a lot of talk recently about being a Switzerland of multi-cloud. So that's what I think the AVI messaging has been for a while now, that AVI is the Switzerland of load balancing in terms of being able to support any cloud, any environment in the same manner, abstracting away the complexity for the end user. So very quick look into the specifics of how we do this. The controller is typically deployed within the GCVE SDDC. And then you also, as you may know, you have an NSX manager, which is deployed as well as a vCenter, right, for all your workloads. So the controller uses the NSX integration, which we already had, similar to what we have on premises. We benefit from that, and we talk to the NSX manager running within the SDDC we talk to the vCenter running within the SDDC to be able to figure out and discover the segments, the port groups, the T1 logical routers. So all of that information. And with that, we can make a determination of where to place the service engine. The service engine VM is then deployed by the controller on the vCenter. It is connected back to the, along with, of course, NSX manager. And then the virtual service is placed, the NICs are taken over. All of that is happening automatically. And with that, we also have n-way scale out. So we can automatically also program for NSXT for scale out. So if you have a application which you want to scale out active, we can do that, across 4-8 ECMP or 4 to 8 service engines, right? So almost increasing linearly the performance. That's one of the beauties of this product compared to a more legacy architecture where you typically have active standby only. And that session state is lost, because you don't have the same virtual service in general running on multiple service engines. So coming back to the Google Cloud integration, here as well, just wanted to show the complexity and what is the similarity between this and GCVE and what the differences are. So as you can see from the UI perspective from the end user, they are still going to use the same REST APIs to the controller. They will just say, I need a virtual service, I need to create a pool. They can use this same UI or API calls, right? On the southbound or the backend, though, the controller in this case talks to Google public APIs. It uses all these services which Google provides in terms of first IEM, VPC. We can do autoscale integration. So if you have an autoscaling group, then we will look at that and change the AVI pool membership. So in fact, we can also be the decision maker for autoscaling. So you can use metrics which are collected on AVI to be able to do the autoscaling decision on GCP. Right? We have cross-project, support. So all of those considerations have been taken care of, and we have large customers who are driving these requirements. I mean, very, very challenging to work with them, but very enriching as well, given the requirements which they have and the expectations they have, both on Google as well, Google Cloud as well as on AVI running over there. So we'll take a look at some of the use cases of what do you get if you use, first of all, how when we extend your data center, patterns into Google Cloud and GCVE, and then where AVI fits in, right? So we see a few use cases where we want, customers want to deploy or extend or migrate into the public cloud. And each of these have certain benefits and certain considerations from AVI as well, right? Most of this is driven by DNS-based load balancing or GSLB, global service load balancing, which forms an outer layer or a higher level layer, right, before the traffic is going to one of these sites, right? That's what the function of GSLB is. In case of active deployments, what you would want, this is a very common use case where you have the same application you want to run across multiple sites. It would be, let's say, one on-premises site and a couple of public cloud sites, or it could just be, multiple public cloud sites. Let's say you are a global organization with public GCP and GCVE presence in EMEA, US, and APJ, right? So in that case, and you're running the same application there. So what you could do there is run GSLB on top and have, algorithms such as geo-based. So whoever is coming from India can go to the nearest site, which is probably in APJ, based on the IP addresses, right? Each of these sites, that determination is made by the AVI GSLB, and it then sends back the DNS response to the end user to go to that particular site. And there the local load balancing happens on that site, right? So that's one of the common use cases. The second is disaster recovery, where you would want to use the second site as a as a disaster recovery, as a standby site. So it's not active all the time. It is primed, it has been configured and provisioned, but maybe it is not consuming as many resources, or if your failover requirements are more stringent, then it is sort of a hot standby as well. So in that case, as you will see, we have a different architecture where GSLB can also help. The third option we see is migration. So let's say, and this is something which we're seeing a lot more, especially in the past couple of years. Marcus can also provide his feedback. So in this case, a lot of customers are on a plan to vacate their private cloud and go into a Google Cloud or a GCVE. So there, the customer wants to have both of them running at the same time for a particular period of time, but then ultimately cut over from the on-premises to their new public cloud environment.
Abhinav,
So
sorry to interrupt, but there's a question, that how does one purchase AVI for GCVE and GCP use cases? Can we get
sure.
this from the Google Cloud Marketplace today to pay and also install?
Sure, I'll cover that in a few minutes when we have the licensing slide. Yeah, that's a great question. We'll get to that. Yeah. So coming to the more on the DCDR, the lift and shift use case, as I was just mentioning, the site one is the original site. It is typically the on-prem data center, and you have a DNS system running over there. One of the ways to use AVI over there is to configure GSLB, AVI GSLB over there, right? And prime this site for migration. In the meantime, you also do your migrations of the application onto the final site, which in this case I'm showing GCVE, but could also be GCP, right? So in that case, you're running this site as a standby site. Your customers are not getting this because you're getting you're just doing testing. Once you have this all ready, what you're going to do is first of all advertise both sites so that you're sure that both are working. And then finally, once you're comfortable with the final site being all production ready and being able to handle the entire load, you will just decommission the the original site. And with that, the GSLB is being used for a lift and shift operation from public cloud, from on-premises data center to GCVE. The other other use case we saw was disaster recovery. Here, for example, we have GSLB ready and running, but we are typically advertising only the active site, right? The standby site is provisioned, but it is not advertised because we don't have everything. We don't want to use that unless there is an actual failure of the active site. Let's say the active site goes down, then GSLB will figure that out. It is doing health monitoring across both sites, and then it will just move to the DR site once it is ready, and then your customers will or end users will be able to go to that. Right? So with that, you have scenarios such as business continuity, and then depending on what your SLAs are, you can either keep the standby site off, completely hot, always running, or we have, thanks to automation and infrastructure as code, we also have customers who start building out that site, applications on that site, as and when they see a degradation on the original site, on the active site. So with that, at a click of a button, you start the stack of deployment on the standby site. Once it is up, you do this transition to the standby site. Any questions around this before we get into some of the demo and the licensing aspects? So I'll cover the licensing and then we can get into the demo, given we had the question. So purchase of AVI. So AVI, one thing which we have done is that our metric of consumption is the actual usable capacity on the service engine, right? So the controller or the control plane is not charged separately. What we have is the service engines or the service cores, the number of vCPUs which are consumed, right? We take care of hyperthreading. So if it's a hyperthreaded, VM, then you don't pay double. All that is taken care of. So with that, the service cores is the metric. So if you have more capacity required, you just buy more service core licenses. The licensing is today 1 year, 3 year options, prepaid term SKUs, which are available, which includes 24/7 support and all of that, right? And these licenses are applicable across on-premises, across GCP, across Google GCVE, any of these environments. So there is no separate consideration on where you're running as of today, right? In terms of the other part of the of the question about can we get this from Google Marketplace? So that's not something which we have today, but yeah, we are excuse me, in discussions, and once we have some more details, we'll definitely share this with the with the audience. Any other questions, Surbi, Marcus? So what I'm going to do is do a very quick demo, then we can get into any other questions. Feel free to put your questions on the chat window. So let me just fire up my browser. Second. Yeah, so the demo which I have is more on the it's basically the demo system which we have. And what I'm going to do is I'm going to log on to this. This demo system is running on premises in our data center in the US. It's fully role-based access control. So I'm going to have to use my, it's basically doing a SAML with my VMware email address. And once we have this, I've dropped into this system, which is providing you with an initial application view. Right? Recent changes to the UI from earlier, as you've seen our KB articles, is that we are moving towards a more consistent user experience with the VMware products and within. So that's where you see some of the elements change recently. Day zero configuration, as I mentioned, is just deploy the controller, or if the controller is SaaS, to connect to it. When I say connect to it, it basically means a cloud connector, which is the integration with the environment. That's something which we do with the infrastructure tab over here. So once I go to the infrastructure tab, typically this is all going to be blank. What I'm going to do is configure a cloud. So for example, over here I have a vCenter cloud available. And in this, what I have is I've created the vCenter IP address, the username, the password. I'll also give details around whether I'm using an IPAM. For example, we support Infoblocks as an IPAM, as well as any third-party IPAM. You can use it with its APIs. Right? We can use Avi as a DNS provider, as well as integrate with other DNS as well. Right? Once I click on next, what's happening is that the controller is making API calls into the system. So in this case, into the vCenter, it authenticated me, and it has done a discovery. So in real time, it is showing me what are the data center elements which are available, what are the networks which has discovered, right? What are the port groups and the systems which are discovered. So all of this information, once I click on save, what I've done is that I have done the day zero, day one configuration of having this cloud connector ready. Similar to this, in case of GCVE, we will have an NSXT deployment as well. So the cloud type will be NSXT cloud. Rest of the things stay same. So in that case, I'm going to ask for both an NSXT manager address as well as vCenter details, right? Because here you also need vCenter along with the NSXT. So as you can see, all of this is done once and you're good to go. The next action is then, note that in this case, after this, we are not creating the actual load balancers or the service engines. And the reason is because we haven't told, we don't have an active application or a virtual service yet. Once we have that is when we will go and create the service engines, right? So as I mentioned, this is completely, RBAC. So this was the admin tenant. We don't want to, do too much over there. We could break things. So the other thing which we'll do is we'll do it in the demo tenant, right? So here I have more of an application operator role. And this is something which you can give to your end users, right? Your application owners. You can set this up and you will give them access so that they can create a virtual service, for example. They can manage that virtual service and application, but not touch the infrastructure bits, right? That flexibility is all there. So I'm going to create a quick virtual service over here. It is asking me whether I can auto allocate the IP address because I have selected that. It discovered the VIP, port group which is available and the subnet. It will punch this FQDN into it. Let's enable SSL, as well as port 80. So you can enable both. You can see that we automatically have certificates. So we have full certificate, management as well. So you can import your certs, you can sign CS certs, all of that is available. And then we'll create a pool. So the pool is the backend servers. So I'm going to just, select the defaults here. What's interesting is that I can select, so I don't need to remember the IP addresses for the servers. All I'm going to do is I'm going to select the management network. And with that, I can just select the servers by name. So now this is interesting in terms of, in case of GCP, for example, I can use auto-scaling groups over here instead, as I just mentioned. In case of NSX, we can use NS groups as well, right? So with that, you don't have to figure out the static membership. It can change dynamically as required. Right? Click through save. Right. We're going to click next. You can configure policies, as I mentioned, from full layer 4 through layer 7. Anything complex you can do, data scripts, which are Lua-based data manipulation APIs. And that's it. You're good to go. So once I clicked on save, what's happening is that the system is trying to figure out if it already has a service engine. In this case, it had. And what it did is that the controller went and pushed the configuration to the service engine in the matter of seconds. So this service engine, one service engine now is serving this, this application. If I go to this, it should show me, a standard web page. That is the power of the automation which we have built. Anything to do with the actual provisioning of the service engine has been taken care of. I just said that I need this virtual service, and everything is done automatically. If the service engine was not available, then the controller would have done an API call into GCP, or in this case into vCenter, and say, hey, spin up a service engine VM. The SAVM would have spun up, it would have called home to the controller, and then the controller would have then ensure it has a license, and then push the configuration down to that service engine. So it takes a few more minutes, maybe 4 or 5 minutes, typically, but that's all it requires. The other there is no other action required from the customer or from the end user. Coming to the other part, which Marcos also mentioned in terms of analytics. Here, as you can see, what we've done is that, and this is the initial view which I was dropped into, right? What we have is a very application-centric view, from the ground up. So in this case, we are providing you with visual cues into the health of each of these applications. For example, this one, the AVI demo, it's been running for a while. It has 3 pools. It has multiple servers. Most of them are, fully green. One of them is down, and that is, you don't even have to go into the SSH or figure out. You can just figure out over from here what the issue is. You can see that this service engine is marked down by R being unresolved. So basically, not even network is working over here, means something on the VM itself is wrong. These things change as, and we have various performance metrics which we use to create that score, including resources, including anomalies. So if there is a trend, sudden change in trend, for example, sudden scale up of traffic, then we can, the score will be pointed, and you can get an alert based on these values, right? And then of course security in case of things like health, SSL sort, self-sign sort, insecure ciphers, things like that. Coming to this, to the actual virtual service as well. This is the initial view which is called the analytics view, and over here we have various trending, time series information. As you can see on the right side, we have things like throughput, number of connections, number of requests, what is failing, right, over a period of time. This can be, all down to past year. So we aggregate this, and we lose generality as we aggregate it, but we provide you with a good, statistical sample and trending. So in this case, how does this actually help with troubleshooting? So here, as you can just see, even by looking at this end-to-end timing graph, I can see that every few hours, I'm getting a spike in the end-to-end time. And what is this for? This could either be for the network, it could be for the application, right? These are the typical things which took two typical components. So here you can see that the client RTT has been same around 30 milliseconds. Server RTT has been same. It's the application response which has increased, right? The yellow, the orange bar. And we've also, the anomaly detector has actually looked at it, and it has flagged it over here by this lightning sign. So with this, you can go and figure out that every few hours you are having a bad user experience at a high level, and the issue is not with the network. So don't go and blame your service provider, or don't blame the load balancing team. It is the application owners which need to look at it. Right? That is the power of the system. We also saw over here that there was a certain drop, and we also see why or some hint as to what happened, and probably the config update happened, because of which maybe this required a disruptive change of connections, so all connections went down and then came back up. So this is at an aggregate view, but what if you want to go to the next level and figure out, you saw that there are end-to-end timing has increased, or the application response time has increased for some uh, uh, request. So what I'm going to do is, let's look at the past 3 hours of data, and we have this. This is all the requests which are going through the traffic through the load balancer. We throttle this, but this provides a very good view of what requests are coming in, how these are being processed. So we have so many data points for each request which are there. The client side, what algorithms, what SSL they're using, what user agent, what OS. The server side, where which application member serviced it, what were the headers exchanged, right? So with this, you don't have to do Wireshark and PCAP to figure out what's initial troubleshooting. So let's look at this, specific from the previous one. We saw high app response time as one of the things which was shown in the analytics, right? So I can just do we call this a Google-like search, where we just type in over here, and this filter gets applied. And with that, you can look at some of these summary data. Is it a particular server IP address, for example, which is providing having the app response time? So you see almost 100% is from this application server, right? So with that, you can say that out of 10 servers, this is the one which is having that issue with the app response time. So you can go to your application devs and tell them, hey, this one needs some care to get to the proper SLAs and proper solution. So I could go on and on, but in the interest of time, I'm just going to talk about one more thing in terms of the security posture, and then we'll open it up for more questions, right? This is the SSL certificate view, the security view. If there are any layer 4, layer 7 attacks happening, we have a bunch of those which we detect, and you could look at it. Currently, we're not running any, so this is blank. The SSL view provides you with a good information as to what if you have an application which is has a thick client or a thin client, multiple mobile clients and all, right? You can figure out what these ciphers are which are being used. So tomorrow, if let's say there is a vulnerability in a particular cipher and you want to block that, you can figure out from here as to how many of your users will be impacted, right? How many users are still using it, or you can use this to retire old ciphers or non-performing ciphers, and be up to date on your security posture as well. Right. All of this is also available through the whatever is you're seeing on the UI is available on API. We are an API first, so all of this is actually API calls into the system. Nothing separately done for the UI only, or from SDKs. In addition, all analytics can be streamed to time series databases like Grafana, and the logs can be streamed directly from the service engine to log systems like vRealize Log Insight to Splunk and all of that. Great. So that's what I had for the demo. Going back to this presentation, Marcos, if you want to take over some of the closing comments.
Absolutely, Avinav. Let's just flash that slide there.
Yes.
It has the links and the call to action.
Yeah.
Yeah. So again, thank you, VMware, and thank you everyone for attending today. As we share this presentation, you'll see some links and a call to action, so you can visit our Google Cloud VMware website, where you'll learn more about availability of the solution, cost of the solution, and promotions that you can leverage to get started with consuming this important resource. Reach out to your VMware sales representative or your Google sales representative if you're interested in exploring some of the options and use cases that we meet with GCVE. There's also a solution brochure that summarizes everything that I've covered today in the capabilities and features, as well as the benefits of integrating NSX Advanced Load Balancer in GCVE. And then there's also a web page that explains, a white paper that explains how to integrate the load balancer with other GCP services. And as always, we have videos and tutorials demonstrating all this. With that, and once again, I want to thank VMware and I want to thank the attendees for inviting me. It's truly a pleasure and an honor to collaborate with VMware, and thank you for joining us today.
Yep, thanks a lot. Thank you so much, Marcus, for your partnership on this, and thank you everyone, the attendees, for listening in. And do reach out to us, as Marcus mentioned. Happy to help in any way possible.
Thanks, Marcus. Thanks, Abhinav. Bye.
Thank you.